Welcome to EduRev. Today, we're going to dive right into the fundamentals of probability. My goal is to help you turn that feeling of uncertainty into real understanding. We're going to break down the language of chance and give you all the tools you need to really master it. So let's kick things off with a question that's really at the heart of all this. How do we actually measure uncertainty? I mean, think about it. When you flip a coin, you know it's going to be either heads or tails, right? But you have no idea which one it'll be. Well, probability. That's our tool for putting a number on that what-if feeling. All right, so here's our game plan for today. First, we'll tackle what probability even is. Then we'll get into the basic building blocks. After that, we'll calculate our very first probability. Then things get a little more complicated, but we'll handle it. And finally, we'll wrap it all up with a quick recap of your new toolkit. Okay, let's dive right in. First things first, we need to get a really clear, simple definition for this super powerful idea.
So I want you to just think of probability as a way to put a number on chance. It's a scale, really. On one end, you got 0, which means something is absolutely impossible. On the other end, you have 1, meaning it's a sure thing, it's certain. And pretty much everything else in life, a coin flip, a weather forecast, rolling dice, it all falls somewhere in between 0 and 1.
And here's something that's actually kind of cool. If you know the chance of something happening, you automatically know the chance of it not happening. They're just two sides of the same coin. So, for example, if the weather forecast says there's a 0.3 or, a 30% chance of rain, then the chance of it not raining is just 1 minus 0.3, which is 0.7 or 70%. Pretty straightforward, right? Okay, now that we've got that down, let's build on it. Before we can actually start calculating anything, we've got to learn the lingo, the language of chance. There are a few key terms we need to know.
So what's a random experiment? It's basically any action where you know all the things that could happen, but you just don't know for sure what will happen. Think about rolling a die. You know it could land on a 1, 2, 3, 4, 5, or 6. But until you actually roll it, you have no idea which one it's going to be. And you see these random experiments everywhere in life, right? Tossing a coin, rolling a die, pulling a card from a shuffled deck. In every single one of these cases, the final outcome is just left up to chance. All right, this next term, sample space, is super important. It's just a fancy way of saying the complete list of everything that could possibly happen. Seriously, before you can solve any probability problem, you have to map out this entire universe of possibilities.
So, for example, when you toss a coin, what's the sample space? It's just heads, tails. That's it. If you're rolling a standard die, it's 1, 2, 3, 4, 5, 6. And I'll say it again, figuring out the sample space is absolutely the first step you have to take. Okay, so if the sample space is the whole pizza, everything that can happen, then an event is the specific slice you're interested in. It's the one outcome or set of outcomes that you actually care about for your question. Like, what's the chance of getting heads? Or rolling an even number? Or drawing a king? Those are all events. All right, we've got our building blocks, experiments, sample spaces, and events. So now, let's look at the formula that puts it all together so we can actually calculate a probability. This is where the magic happens. This right here, this is the key. The formula is super simple. The probability of an event happening, we write that as P of E, is just the number of ways you can get what you want, divided by the total number of things that could possibly happen. It's a simple ratio, but man, is it powerful. Okay, let's put this formula to the test with something a little trickier. Let's say you roll 2 normal 6-sided dice. What's the probability that the sum of the 2 dice is greater than 9? Go ahead, take a second and think about it. What are your favorable outcomes and what are your total outcomes? Did you get it? The answer is 1/6, and here's why. First, let's figure out the total number of outcomes. You have 6 possibilities for the first die and 6 for the second, so that's 6 times 6, which is 36 total possibilities. Now, how many of those add up to more than 9? Well, you've got 4,6, 5,5, 6,4, 5,6, 6,5, and 6,6. That's 6 favorable outcomes. So you just do 6 divided by 36, and that simplifies down to 1/6. See? Not too bad. Okay, so we're getting pretty good at handling single events. But what happens when things get a little more complicated? What if we want to know the probability of one thing or another happening? Or what if one event actually depends on what happened before it? Well, for those or questions, we use something called the addition theorem.
Basically, you add the probabilities of each event separately, but then, and this part is really important, you have to subtract the probability of them both happening at the same time. You do that so you don't accidentally count any overlapping outcomes twice.
Now, this next idea, this is where things get really fascinating. It's called conditional probability, and it's all about updating what we know based on the new information. It answers the question, what's the chance of A happening now that we know B has already happened? I mean, this is the logic behind everything from medical diagnoses to how your email filters out spam. It's basically probability that learns as it goes.
Let me show you what I mean. Imagine a bag with 5 black balls and 4 blue balls, so 9 balls total. At the start, the chance of pulling out a blue ball is 4 out of 9. Simple enough. But what if you pull out a black ball and you don't put it back? Suddenly, the whole game has changed. The sample space just shrunk. Now there are only 8 balls left in the bag. So what's the probability of drawing a blue ball now? It's 4 out of 8, which is 1/2. See how that first thing we did totally changed the probability of the second? That is conditional probability in action.
Wow, we have covered a lot of ground, haven't we? From the basic definitions all the way to some pretty complex rules. So let's do a really quick recap of your new probability toolkit, just to make sure these key ideas really stick. First and foremost, always start with your sample space. That's the complete list of every possible outcome. You just can't solve the problem if you don't know what's possible. Second, our core formula. Don't forget it. Favorable outcomes divided by total outcomes. That's your bread and butter. And last but not least, remember that probabilities aren't set in stone. They change as we get new information. That's the whole idea behind conditional probability, the chance of A given that B has already happened. So I want to leave you with this one last thought. Probability, it isn't just some abstract thing from math class. It's a real tool for thinking about risk, for making smarter decisions in a world that's full of uncertainty. So my question to you is, how are you going to use this toolkit in your life? Now, if you want to practice these concepts and really dig into more advanced topics to help you ace the GMAT, go and download the EduRev app. It's available on the Play Store and the iOS App Store. Thanks so much for joining me today.